Today we're talking about more transformations. We're going to be talking about things that kind of flip across the x or y axis, and we're going to talk about stretching a function or condensing it, making it smaller. So to start with, we're going to talk about flipping a function. So here's a function. We're going to call it our parent function. We're going to have this one in black. F of x. That's what we've been using. Now, it's going across 1, 1, 2, 2, up to 3, 4, and down to 5, 1. This is what our graph looks like. Now, if I want to flip it across the y-axis, it's like we're just taking it and putting it over here. We would represent it with the f of negative x. That's how we would change our function. This would now become g of f of negative x. What happens here? This comes over here. This is now, instead of 1, 1, it's negative 1, 1. This is negative 2, 2. This becomes negative 3, 4. And this one becomes negative 5, comma 1. There's our graph. We just flipped it. Changed the x's to negative. And if you can see, the negative sign goes with the x's. Those are the ones that changed. We just kind of flipped them, made them the opposites. And everything else remains the same. If we want to flip it across the x-axis, all right? Now, instead of the x values going from a positive to a negative, it's going to be the y values. And we would represent this as the negative function of x, because we're adjusting the end problems, the y values, just like in the previous problems. So instead of, this is going to be 1, negative 1 now, this point. This point is 2, negative 2. This one is now 3, negative 4. And this one here is 5, negative 1. And we just flipped it here. All the distances to the points are the same. If you notice, we're 1 unit away from the x-axis, 1 unit away here. 2 units away here, 2 units here. 4 units here, 4 units here, and so forth. And the same can be said here. We have an axis of symmetry that the x and y axis are creating, kind of like a mirror. So again, when we see flips, when things are flipped upside down, it becomes negative f of x. If things are flipped across the y-axis, left to right, then it's f of negative x. So you want to keep that down. If you need to, make a copy of this graph. Now the last one we're going to talk about is shrinking something or condensing it. I mean stretching, not shrinking. So let's say we have this function here. This is going to be our parent function. It'll be in red. Let's just say it looks like this. That's our parent function. And I want to stretch it by some quantity. So maybe this is now down here. This point's up here. This is down here. And this one is up here. Well, now, look like that. That's my g of x. Now, when we stretch it, this is going to be multiplying something by greater than 1. We want to make it bigger. So this might be some number, let's call it 3, times the f of x. We're just taking if you notice, our x values are the same. We're just stretching out the y values in this case. And that's why the 3 is on the outside, not connected with the x. So this number is bigger than 1. It's stretching it out. Just like this did. We're stretching it out from our various points. If we want to condense it or make it smaller, let's say instead of 3, we change this to 1/2. Now this might look like that. That would be kind of compressing it down, pushing it down. If you notice, the x values are still the same, boom, 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 but the y values are changing. We're condensing it, making it a smaller curve or a smaller relationship. That's stretching and that's condensing. Now I want to review everything that we've done so far. So we did vertical translation. This was g of x would equal f of x plus c. And c is going to be a constant. Some number we're adding or subtracting. If it's a horizontal translation, it's g of x will equal the function of x minus our constant. Remember, if it's a negative number, it makes it go to the left and then become a plus. So that's what we covered the first video. This video, then we had a flip across the y-axis. G of x equals the f of negative x. That's changing the x values, it's flipping it across. A flip across the x-axis, flipping it up and down, that'd be g of x equals negative f of x. That'd be flipping it this way. If we are stretching our function, we're multiplying by some constant where c is greater than 1. This could be 2, 3, 5, 10, a billion. It just needs to be bigger than 1. If we're condensing it or shrinking, kind of like the word shrinking a little bit better, our c times f of x, g of x equals g of x equals, and this is where c is less than 1. 1/2, 1/8, 0.54, just something smaller. Write this down. This should be your little study guide to look off of, because we're going to be combining a few of these together, up to maybe 4 or 5 of them, so we can see how we can move these around and adjust these functions. Again, copy these down, put them on a file card if you have to, so you have them handy. This should help. Use this on your next assignments. I'll see you next time.